Hello everyone and welcome to Machine Learning Tutorials. In this tutorial I will explain you how to perform multi-class classification by using Scikit-learn library and Python. Particularly in this video you will learn how to load a dataset from the Scikit-learn database. Then you will learn how to split the data into the train and test datasets. Then you will learn how to scale the data. Then you will learn how to employ the support vector machine classifier. And finally, you will learn how to predict the data on the basis of the test data set. Before I start, I would like to mention a few things. First of all, those of you who are my subscribers or who are following my channel know by now that I always create a post that nicely summarizes everything that I will explain in this video. And consequently, here is the post. This post contains equations and Python code. Secondly, it took me a significant amount of time, energy, and planning to create this post and this video. So I kindly ask you to press the like and subscribe buttons. Thank you very much. In order to explain how to perform classification tasks in Python, we will use the iris flower dataset. And you can learn more about this dataset by clicking over here and by following the link. This link will lead you to the Wikipedia page explaining this dataset. This dataset is very important in machine learning and in pattern recognition communities. Basically, the problem is to classify three subspecies of the iris flower. The three species that we want to classify are Iris setosa, Iris versicolor, and finally, the third species is Iris virginica. We can classify different subspecies by measuring certain geometrical features of the flower. For example, we can measure this width over here, L1. Then we can measure this length, L2. And we can also measure some other features that I will not explain here in order to make this video as short as possible. Then we can perform these measurements for a number of different flowers and we obtain different samples. So the sample can be, for example, 0.1, 0.5. Then the next sample can be 0.2, 0.7, etc. Now, for every measurement, that is for every sample, we actually know the class that this sample belongs to. For example, this can belong to the class Iris setosa, and let this class be denoted by number 0. Similarly, the next sample can belong to another subspecies, let's say class number 1, etc. So in this way, we can create a data set that can be used for classification. Now, let us go back to my original post. The iris flower dataset is actually included in the Scikit library, and that's a very nice thing about the Scikit library, as you will see later on when I explain the codes. This library has a number of different data sets, and you can test your algorithm on these data sets. The particular iris flower dataset contains actually 4 features or 4 measurements. I only explained 2 measurements. Actually, the features are the length and width of the sepals and petals. Sepals and petals are characteristic parts of a flower that can be used to distinguish between different species. The 4 features are actually given over here. They are sepal length, sepal width, petal length, and petal width. The input data for classification looks like this. It's given over here. Every column corresponds to a certain feature. For example, this column corresponds to sepal length, this column corresponds to sepal width, this column corresponds to petal length, and this column corresponds to petal width. The rows are actually the samples. That is, the rows correspond to different flowers and the measurements performed. Since there are 3 subspecies that we want to classify, there are 3 classes in our output data set. And these classes are Setosa, Versicolor, and Virginica. And these classes are denoted by 0, 1, and 2. Our goal is to train the classifier that will properly predict the class or subspecies for a given sample. Let us illustrate this graphically. Let us assume that I measured these features: 5.4, 3.9, 1.7, and 0.4, and this is my sample. My classifier, that's represented by a block over here, should predict a proper class on the basis of this sample. So it should give me either 0 or 1 or 2. And we want to train this classifier on the basis of the collected data. Okay, so let's see how to do that in Python. First, we need to import the necessary libraries. You can see over here that we are using the name Scikit-learn. That is, we are not using Scikit-learn. In Python, we are using Scikit-learn. The first step is to import the dataset database. And we simply write from Scikit-learn import datasets. Then, we need to import the standard scalar. I will explain the purpose of the standard scalar in the sequel. Then, we need to import train test split function. This function is used to separate the data into training and test data sets. This will be explained in the sequel. Next, we need to import the classifier. We are using the support vector machine classifier. And finally, we import the NumPy library. Okay, so let's import these libraries and load the data set. Over here, we will load the data set. Let's explore the data set a little bit. So here's our data set. Let us see the keys of this data set. So the keys are data, target, frame, target names, description, feature names, file name, and data module. So let us further explore this data set. For us, the most important part is the data. This is basically a matrix representing the measurements. We can obviously see that we have 4 features, that is, we have 4 columns. And let's see the targets. Okay, so here are the targets. We have 3 classes, and we can see that the targets are sorted. And we don't like that. We don't like this perfect ordering. We will later on shuffle the data set. Over here, we will extract the input and output data set. When I write capital X, this means that this is an input data set, and when I write capital Y, this is an output data set. And over here, we extract the input and output data set. Now, the first step is to split the data set into train and test data subsets. And we do that by using train test split function. And over here, we specify the size of the test data set. In this case, the size is 0.3. This means that 30% of samples will be actually test samples. Okay, so let's execute this part and let's see what will happen. Okay, so let's see our X train. Okay, so here's our X train. Let's see Y train. Perfect. You can see that Y train data set is shuffled, and this is what we want. So this function over here, train test split, automatically shuffles the data. Moreover, it performs a stratified sampling. The next step is to scale the data. And in order to scale the data, we are using the standard scalar class. This step is a very important step that you will most likely have to use in other machine learning projects. And consequently, let us explain this step in more details. Standard scalar will remove the mean and scale the data such that the scaled data is zero mean with a unit variance. Roughly speaking, this is done since data sets with wide variations of values across the samples and features can create numerical difficulties when training the classifiers or even neural networks. Consequently, it is always a good idea to scale the data. The standardization is performed according to the classical definition of the z-value in statistics. So what do we do over here? We take our samples that can be shown over here. Every row is a sample. Then we compute a mean over these samples. That is, we compute the mean of the samples, and we compute the standard deviation of the samples, and then we simply take a sample from here, this is our x, subtract the mean, divide by the standard deviation, and we obtain z value. And z value is guaranteed to be zero mean with unit variance, that is, with unit standard deviation. And in that way, we scale the data. Of course, there are other types of scalars that I will not explain in this video. Here's how we scale the data sets in Python. First, we create a standard scalar object called scalar1. Then, we call the function fitTransform, and as an input to this function, we provide xtrain. The output will be xtrain scaled. And this output corresponds to samples that are scaled. And here are the samples. Then we need to scale the test data set. Consequently, we call the function transform, and as the input we provide the xtest. And the output corresponds to samples that are scaled. That is, the test samples that are properly scaled. Next, we need to create a classifier. In this video, I'm using the SVC classifier, and this classifier implements the support vector machine classification method. In particular, this classifier performs one-against-one classification. And let us explain this classification approach in more details. Basically, the support vector machine classifier uses one-against-one or OVO classification strategy. The idea is to split the problem into a series of binary classifiers. So, since we have three classes, class 0, class 1, and class 2, we can actually form three binary classifiers. The first classifier will classify class 0 against class 1. The second classifier will classify class 0 against class 2. And the third classifier will classify class 1 against class 2. Each classifier predicts a single class or probability of a sample belonging to a certain class. And then we use the majority of votes strategy to find the most appropriate class. And briefly speaking, that's the main idea of this classification approach. Over here, we create a classifier. After we create a classifier, we need to fit the classifier. That is, we need to train the classifier. In order to train the classifier, we use the xtrain and ytrain data sets. Once we trained our classifier, we need to test the performance of that classifier. To test the performance, we use the predict function. This function will predict the output, that is, the classes, on the basis of the input. And as the input, we provide the test data set. After we do that, we need to compare the predicted outputs with the true outputs given in the test data set. And we do it over here. So let's see how this works in practice. Over here, I create a classifier. Then I train the classifier. And finally, I perform predictions. And let us see this output. Okay, so these are predicted classes for certain inputs. So these are the sample. So this classifier is saying that this sample over here belongs to class 2, this sample over here belongs to class 2, this sample over here belongs to this class, etc. Now, how to investigate the accuracy of the classification process? Well, we can simply perform comparisons. We compare the predicted outputs with the true outputs from the test data set. And let's see the result. And here's the result. We can observe the following. The first sample, that is the sample over here, is accurately predicted. That's why we obtained true here. However, we can see that, for example, the fourth sample is not accurately predicted. That is, this sample is not accurately predicted. However, from here we can see that we have more truths than false Boolean variables. Consequently, we can observe that the prediction is very good. Of course, we can also predict a single sample. We can do that by just specifying the sample over here and by reshaping it and calling the predict function. And here's the prediction for the fifth sample. It's basically second class, and let us see the true value, and the true value is 2. Okay, that would be all for today. I hope that you liked this video. If you like the videos I create, please press the like and subscribe buttons. Thank you very much and have a nice day.